The other one's at the end of the unit. So day 2, parallel and perpendicular lines. Parallel lines are lines that are equal distance to each other at all points. Okay, so they're equal distance to each other at all points. The symbol, so lines that never meet, this is the symbol for parallel. 2 parallel lines is the symbol for parallel. So an example is railroad tracks. Perpendicular lines always intersect at a 90-degree angle. So remember this little box is a symbol for a 90-degree angle. Another symbol for a 90-degree angle, or perpendicular, is an upside down T. Yeah, because a T, right, the vertical and horizontal line, they make a 90. So an example of road intersections or railroad intersections. So can you label the following lines? So our set 1, we'll call this guy L1, line 1. The second one L2, line 2. Line 3 and line 4. And then L5 and L6. So we're just going to label our lines, which one's which. And so what we're going to do is we're going to find the slope of each line. Now it says either rise over run or using the formula. Let's use rise over run. So set 1, we have 2 lines. We want to find the slope of 1 and the slope of line 2. So let's start with line 1. So always start at the point on the left-hand side. So that's this point. And our formula for slope is rise over run. So our first is our rise. Are we going up or down to get to the next point? Up how much? 3, and then right 2. Remember, up and right are both positive directions. So it'd be positive 3 over 2. Okay, next point. So we start on the point on the left-hand side, and we're going up. How much? 3, and then run is 2. So again, 3 over 2. So let's try line 2. Lines 2 are 3 and 4. So set 2, lines 3 and 4. So again, start on the left. Let's start with line 3. On the left-hand side, we're going down how much? Vertically down 4. So negative 4 is down, and then right 1, 2, 3, 4. So negative 4 over 4. So our slope of line 3 and our slope of 4 we're finding. So line 3 was negative 4 over 4. If we reduce that, what does that reduce to? Negative 1. Okay, line 3 or 4. We start at the point on the left-hand side, and we're going to go 1, 2, down 3. So negative 3, and then right 3. So rise over run, negative 3 over 3, which equals negative 1. In the last set, line 5 and line 6, so slope 5, slope 6. What is the slope of horizontal lines? 0. 0. So horizontal lines have a slope of 0. Okay, so what relationship can we make about parallel lines? Yeah, Ben? They have the same slope. So parallel lines have equivalent slopes, or the same slopes. So we could write this as a slope is always equal to its parallel slope. So whatever slope we have is equal to a parallel slope. They're equivalent to each other. 2 lines, their slope should be equal. So now we're going to investigate perpendicular lines on the next page. And again, I'm going to number my lines so we know the difference. I apologize for the lines I made for perpendicular. They weren't as nice, sorry. We'll do our best. Let's line 1 for set 1 is here, and the bottom one is L2. For set 2, we'll go L4 and L3. And then set 3, we'll call this one 5 and 6. L5, L6. So for each set, again, we're going to find their slopes. So we want to find the slope of line 1, the slope of line 2 to start off. So line 1, do your best here. It's supposed to be down how much? Down 2, right 3. I'm sorry. It didn't really land nicely. So for the sake of the lesson, please bear with me. Slope 2, starting at the point on the left-hand side, we're going up approximately how many? 1, 2. If it's starting here, it's like 1 to there, 2, and then 3. Up 3, right 2. So if we're going up 3, right 2, what's our sign going to be? Positive. Up 3, right 2, those are both positive directions. Okay, set 2 was our slopes for 4 and 5. Again, I'm sorry about the way these worked out. Let's start with our 4. 4 we're going, we start with the point on the left-hand side, and then we have to go, our rises first. Are we going up or down? -1, right is 1, 2, 3, 4. So -1/4. It's rise over run. And line 5, again, I'm really sorry about this. It's supposed to be 1, 2, 3, 4, up, right 1. So what would that become? If you're up 4, right 1, remember if it rises to the right, this should be a positive slope. So +4/1. Could you write that another way? Just 4. 4 divided by 1 is 4. Set 3 is going to be a lot easier to do. We have slope 6 and 5 and 6. Uh-oh. This was 3 and 4. I think this was 4, right? The first one, and this was 3. 3 and 4. I'm sorry. You're so kind. Thank you. Okay, 5 and 6. What's the slope of a horizontal line? 0. What's the slope of a vertical line? Undefined. Does anyone remember the symbol for undefined? A 0 with a vertical line through it. A 0 with a vertical line through it. Okay, now let's talk about the relationship between our slopes of perpendicular lines. What do you notice? What do you mean switch? They flip. What's another name for flipping? Ryan? Reciprocal. Remember reciprocal? Reciprocal. So they're reciprocal. What else do we notice? Ben? One is negative and one is positive. So some general observations about perpendicular lines. So perpendicular lines I'm going to write this how you said this first, and then I'm going to write this the math way. So you said 2 things happened. 1, they're opposite signs. And 2, what else happened? They're flipped. So how we say this in math terms is they are negative reciprocals of each other. So why do I say negative? Well, a negative of a negative becomes a positive, and if it's a negative of a positive, it becomes negative. So it's opposite signs and flipped. The math way of saying that is negative reciprocals. The math way. Now there's another thing that's really cool about perpendicular lines. So these are the properties. And so because they're opposite signs and flipped, they have a special property, and that's the following. If I take my slope and I multiply by its perpendicular slope, it'll always equal something. So let's talk about what that something is. So I'm just going to go down here for an example. You don't have to write this, you can just watch. If my slope is 2/5, what is my perpendicular slope? -5, so opposite sign, and flipped. If I multiply these together, so our slope times my perpendicular slope, What does this equal? Well, remember we multiply fractions straight across. Negative 10 over 10. What is negative 10 divided by 10? Negative 1. Let's try another one. If my slope is negative 3, what's the perpendicular? What is this as a fraction? Positive 1/3. Remember, negative 3 as a fraction is 3 over 1. So opposite sign and flipped. Let's multiply. What's negative 3 times a third? So go straight across. Negative 3 divided by 1 times 3 is 3, which equals negative 1. And so whenever we multiply a slope with its perpendicular slope, it'll always equal negative 1. Okay, negative 1. And so the property is that if our slope is a over b, then the perpendicular slope is negative b over a. Opposite signs and flipped. Okay, so example, let's start to apply this. It says the slope of a line segment parallel to the line segment with each slope. So if we have a line with a slope of 4, what would be the slope of a line parallel to it? Whoa, 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 whoa. Parallel. If it's parallel, it's the same. So if we have a line that has a slope of negative 2 over 3, and we have a parallel line, what would the slope be? Same, negative 2 over 3. Again, if we have a line with a slope of 4 over 5, a parallel line will have a slope of 4 over 5. And if we have a line with a slope of negative 5, the parallel line will have a slope of negative 5. So that's when they're parallel, they have the same slopes. Run. Okay, next page. So same idea, but this time, if our line segment has the following slope, what would be the slope of a perpendicular line? Okay, so remember perpendicular lines, negative reciprocals. So you can notice that's one is negative, the other is positive. So if our slope of a line is 4, what's the perpendicular slope? Negative 1 over 4. Good. If our slope is negative 2/3, what's our perpendicular? Positive 3 over 2. If a line has a slope of 4 over 5, what's the perpendicular slope? Negative opposite sign 5 over 4. And if a slope is negative 5, what's the perpendicular slope? Positive 1 over 5. So opposite sign, and we flip the fraction. If it's a whole number, remember, we turn it into a fraction, then flip it. Okay, so let's look at parallel lines. Two parallel lines have slopes 1/2 and k over 4. Determine the value of k. Okay, so let's start off with, what kind of situation are we dealing with? Parallel lines. And what do we know about parallel lines? Slopes are the same, are equal. So what can we do with these two slopes? If I have two slopes and they're parallel to each other, can we set them equal to each other? Yeah. So because they're parallel, we can set them equal to each other. And you can logically solve this, or you can use algebra. Logically, if you have 1/2 equals k over 4, k would have to be 2, right? We had to multiply this guy by 2, so this guy we multiply by 2, and k is equal to 4. Now, they're not always that easy, and if they're not that easy, then you have to use algebra. What kind of underwear does a mermaid wear? An algebra. Okay, anyways. Ha ha ha. All right, try the next one on your own. Try the next one on your own. Two parallel line segments have slope negative 2 over 5 and negative 6 over k. Determine the value of k. So because they're parallel, what do we know about the two slopes? This slope and the parallel slope? They're equal. Slope is always equal to parallel slope. So negative 2 over 5 equals negative 6 over k. What does k equal then? How did you get it? How did you get k equals 15? Negative 2 times 3 equals negative 6, so 5 times 3 equals k. Good. Times 3. Let's try another one. So we were using in both of these that a slope is equal to its parallel slope. Two perpendicular line segments have slopes of negative 2 over 5 and k over 8. Determine the value of k. Determine the value of k. So first of all, we're dealing with perpendicular lines. So if this is my slope, is that equal to my perpendicular? No. Perpendicular slopes, they're not equal to each other. How do we usually get our perpendicular slope? Flip it and make it opposite sign. There's two ways we can solve this. Okay, I'm going to show you both ways. Can anyone think of one of the ways? Kmar. Switch the 8 and the k, flip it, and make it negative. So in order to make them equal to each other, we have to flip it and make it the opposite sign. And then it's multiplied by 4. And then you get k is 20. So to set them equal to each other, I had to take the negative reciprocal. The other option is we learned about a property about perpendicular slopes. What's the property? Remember the property with perpendicular slopes that'll always happen? When we multiply them together, it always equals negative 1. So they give us our slope and our perpendicular slope. And so if we multiply these together, it equals negative 1. And so we just use our good friend algebra. Remember with fractions, when we multiply, we go straight across. Negative 2 times k is negative 2k, and 5 times 8, 40 has to equal to negative 1. First, let's get rid of the fraction first. So multiply by 40 to both sides. You get negative 2k equals negative 40, and then divide by negative 2. So k equals 20. Okay, now the second way seems harder, but the nice thing about it is you just plug it into the formula and then solve. The second one, you have to remember to take the negative reciprocal of that second fraction in order to set them equal to each other. Because they're perpendicular, this is not equal to that. It's equal to the negative reciprocal. This would probably be a multiple choice type question. So if it was a test, either method would be fine. You don't have to use one way more than another. Yep. Can you wait till after the lesson? Okay. When you solve these, you can do cross, yep, multiplication. Okay, please draw the following 3 vertices on your grid. So we have a triangle ABC. Please plot these points. So A was at negative 2 and 3. I'm going to actually put in that point there because we're going to use that. B is at 8 and negative 2. B is 8 and negative 2. So it should be a 10 by 10 grid. 4, 5, 6, 7, 8. Yep. And 4 and 6 is C. 1, 2, 3, 4, 5, 6. C. 4 and 6. So you should have grabbed your rulers or, to the best of your ability, draw these lines. Uh-oh, wrong line. Don't want an arrow. Okay. 1, 2, 3. So my question to you, it says B, the second part of this question says prove that this triangle ABC is a right triangle. So let's talk about what makes something a right triangle. Yes, Scott. So, pardon me, we have one. It has a 90-degree angle. So how does that relate to slope? How does that relate to slope? A 90-degree relate to slope. What are two lines that have a 90? What do we call those? Yeah? No? Perpendicular. So lines that make a 90-degree angle are perpendicular. Perpendicular. Okay, so how does that relate to slopes? Does that relate to slope? How does that relate to slopes? What do we know about slopes of perpendicular lines? Are what? What do we call those? If slopes are perpendicular, what should they look like? Are they the same? No, they're negative reciprocals. Okay, we haven't even done anything yet. This is the logic we need to go through. It says prove it's a 90, okay? A right triangle has a 90-degree angle. Okay, if it's 90, two lines are perpendicular. If they're perpendicular, the slopes are negative reciprocals. Do you see the progression we need to make? So, what do we need to find in order to prove that this is a right triangle? The slope of AC and BC should be negative reciprocals. Why are we choosing AC and BC? Why do we choose this line and this? Does this where it looks like a 90-degree angle? Yeah, so why waste our time with line AB when this angle and this angle do not look like 90s, not even close. Okay, so first let's start with finding the slope of AC. So A is -2 and 3, and C is 4 and 6. So we want to find our slope of AC. Now when you find the slopes of 2 points, what are we going to use? Instead of rise over run, do we have something else? y2 minus y1 divided by x2 minus x1. So we start by labeling our points, x, y, and then what? 1 and 2. So this will be our first point, 1, and this will be our second point, so 2. 1, 1, 2, 2. So we're going to use our formula y2 minus y1, and that is on your formula sheet. Okay, what's y2? 6 is y2 minus 3 divided by x2, 4 minus -2. What happens when we subtract a negative? We add it. Now, if you wanted to put this in your calculator at once, we have to have invisi brackets. 6 minus 3 is? No, we want fractions. 6 minus 3 is 3. 4 plus 2 is 6, which is 1 over 2.5 is a half. So that was with AC. Now what other 2 points do we want to use? BC. So point B and point C. So B was 8 and -2, and C was 4 and 6. So again, we want to find the slope of BC. How do we start it off? y2 minus y1 over x2 minus x1. So we have to label who's point 1 and point 2. xy, and then 1, 1, 2, 2. Okay, y2 is 6 minus -2 divided by 4 minus 8. What is 6 minus -2? 6 minus -2. 8, because if we subtract a negative, we're really adding a positive. So 8 over negative 4 equals negative 2. Are these two perpendicular? Yes. So since AC is perpendicular to the slope of BC, or you can just say line AC is perpendicular to BC, therefore the triangle is, what do we call that triangle if there's a perpendicular or a 90? If there's a perpendicular, we call that, or a 90 a right triangle. Triangle is right, or we have a right triangle. So AC, line AC is perpendicular to line BC, right? Because they were negative reciprocals of each other. So then it's a right triangle. I mean, you could have also found the slope of AB, but it wouldn't be a negative reciprocal of any of the slopes given. You just need to find two slopes that are negative reciprocal, and that means there's a 90-degree angle. Okay, so your homework for today is page 349. Now you can open up, there's a question, I think it's 7 or 8, just because the diagram's not very good. So someone open up to page 330, or all of you to 349. Just 1 second. So question number 7, you can omit from this 3 to 13. Omit number 7, because the picture is not very good.